Evening, Sam.
Hey, Matt. So, good to see you, Bill, after a long time.
Yeah, it's been a while. Got a little distracted there. I had to pay some bills.
Got it, yeah.
Yeah.
So tonight is open discussion project review. We've been working on the lawn tractor primarily to come up with that minimum viable product, getting the software together. People have been working on different aspects of that piece of it. But it's been a learning process. So I think the steering motor is okay using the electric power steering out of the car. That's been very stable and strong. And then just this last month switched over to control the transmission. It's just a lever on for forward and reverse, and switched over to a super servo. I originally put a linear actuator in there, but it started to burn out, and so I switched over to the servo, and that seems to be okay. It's strong enough, and we're able to get the speed constant.
Nice.
So our next steps on this minimum viable product is the odometry, trying to fuse a GPS and the IMU and the wheel encoders. And IMU is a little bit of a tricky, pretty noisy, but the wheel encoders, we are using a pickup sensor. So it only has 30 counts per revolution. So pretty low resolution there. And then been testing the F9P new GPS from uBlocks, and that's been pretty good. It can hold about a 2.5 centimeter accuracy with the base station, and it's pretty inexpensive. It's L1, L2, and it runs around $200 a piece for the GPS.
Okay. Sounds nice. You just put out a single reference base station to work with it?
Bought two of them. Ardu Simple sells a package where they just sell, you buy two of them, the base station and then one for the rover.
Okay.
Yeah.
I worked with something very similar on an indoor project. It was a product from Marvel Mind. It was a combination high audio frequency and then an electronic beacon that they also claimed they'd give you about 2 centimeters accuracy in an indoor setting where you didn't have a view of the sky.
Does that work similar to how the beacon works at an airport?
I don't think so, because you had to put multiple base stations. You know, and it was like a constellation of GPS satellites, except it was for indoor, for much closer distances between the receiver and the position beacons. And then they had mixed an ultrasonic signal with a radio signal to give you those two things. So you triangulate it off. You just had known positions of the beacons, and you had fine resolution on measuring the time of flight from the beacons to your receiver on your robot.
They work well?
Yeah, they worked surprisingly well for us. We did get the 1 to 2 centimeter accuracy on them internally.
Okay.
Gave us what we need. So I used that with that and a combination of the wheel odometry. So it worked pretty well. I was able to compensate for the fact when you goose the wheels a little too much and they slip on a slippery floor. So I was able to compensate for that.
Fantastic. We are sometimes that GPS will drift, and so we're working on fusing those the 3 sensors to compensate for that drift in the GPS. And the drift in the wheel odometry. So
Yeah.
I try to figure out where you are in between that. I don't know what the overall accuracy will be, but it's always a challenge. Sam's been working on a pure pursuit algorithm and planner to do sort of like area coverage, planning or planting or mowing, just a similar search pattern.
Okay.
How's that been going, Sam?
So far, so good. I made some progress. But before I even start getting into that, Bill, I looked at one document which probably you have posted maybe 6 years back regarding to the covariances and how to understand those covariances. It's a beautiful document. I was looking into some covariances and I wanted to understand a little bit better. And I came across that document and I said, I know this guy.
All that stuff, that I did years and years and years ago, I thought would just sort of fade into obscurity.
I know, and then I took a printout so that if at any time it goes away from the internet somewhere, before it goes away, I wanted to have it. So it's in prints.
Yeah.
So yeah, thank you for that. It was just the covariance is stamped. It's the one of the things with the poses and stuff. Important. So I actually wanted to take a look into the covariances because sometimes it goes out of control and then you get into the trouble for sure. So in that line, just wanted to mention it. So because you're here.
Thanks. Glad it was useful.
Absolutely, yeah. Thanks for posting that. Actually, it was in 2012, I guess.
Yeah, sounds about right.
Okay. So yeah, regarding to the PR pursuit, and obviously I looked at many implementations. Nothing yet we could use directly, but after following so many implementations, I came to a conclusion that it's easy enough if you understand it, and then easy enough to implement it. Although I have now laid out we got two path planner and the path tracker, and then I'm working on sort of path tracker, which is it's actually using the PR pursuit algorithm. So I laid out actually and take kind of a first stab at it, and laid out that how I'm visualizing the whole flow, about that node, which is basically a path, the path tracker, and then I started. I can share and I can show it to you guys whatever the progress that I made. So basically, before I actually get into the code, so I wanted to actually build a background. So the lawn tractor, it's the package, and the simulation is currently working. So that's our current package where you can get the simulation working. So you can see that we're using the stage RS to get the the odometry data for the simulation, and everything's around. We're using the Mobase. You can sort of use that to simulate the tractor that would go from point A to point B. We also got the URDF for the overall the frames, which is right now what we have, which is basically we have the map frame, we have the odom, we got the base link, we got also the kind of two frames attached at this point. So one's the GPS and the one's the camera frame. So that's a sort of our TF frame topology, and then we wanted to grow on top of that. So it works up till simulation now, and then the next stage that we're planning right now is we looked into the Mobase, we looked into the other packages, and see that if I have a path that I can actually feed into, I need something that actually constantly track that path. I don't want it to actually, I don't want to give point A and point B and let the current standard, the ROS packages figure out the optimal path, because our use case is mostly different the way I see it. That could be it's just the zigzag path, and you want it to start at point A, and then you want it to stop point B, and not necessarily stop anywhere in between. There are certain other things we also look at, if you utilize the action server, which is the simple action server, that would actually stop at every point. which we don't need. We need something to like kind of work like a pure pursuit. So we got into the we looked into the pure pursuit packages, that was already written for RS, but just a different purpose. There's no agricultural purpose at this point. But all of those packages plus their the direct Python programs that actually gives you an insight of what's in the pure pursuit. And I think it's just one of the oldest algorithm, probably the robotics the people would use, and there are a lot of the adaptive and the optimized the pure pursuit that came afterwards, and there are a lot of other probably the algorithms too that you can deploy, but I think this is the simplest one and it fits the use case. I talked about that also probably into the one of the last meetings. So, and then we decided that, okay, well, this, we wanted to actually create a node, which would right now, like if I feed the path in terms of the path points, like the waypoint file, if I have 100 points, which defines a path, our path tracking node should be able to navigate a vehicle or a tractor, onto that path, starting from whatever the closest point is to all the way to the end. Could be a constant velocity, could not be a constant velocity. You have so many other tuning parameters. The overall, I'm visualizing that at the end of the node, what's the outcome, the output of the node is I do get the velocity in terms of, the x, which is the forward direction, which is my linear x. And I do get the orientation control, which is the Ackermann steering control, which would give me the orientation about z. So it will be my angular z and then angular velocity at which my steering would turn. So that would be the output of it. And visualize both the points. The one is right at the base link, which is right at the rear axle center. That's where I would measure the velocity of it, which is the forward x. And right at the the front wheel center would be my Ackermann steering, the angle frame. So that would output, that based on the certain restricted, limited parameters, what's your turning radius would be, what's your maximum turning angle would be, sort of things, based on that, you would restrict that and you would output that angle and the angular velocity, in that, at that point, in kind of in sort of Ackermann frame. So that's how the whole, the visualization, of the whole vehicle is right now. I mean, just stop me if something's not right or something's not jiving, kind of deal. So with that in mind, I started writing the path tracking node, and let me share that. The code right now. Let me share my screen. So far so good, right, guys? You're with me?
Yep.
What's okay? All right, so I'll share my screen, and again, I'm not an expert in any way in ROS at this point, but I try my best, to sort of write a node which is, quite clean, readable, and then I'm taking the top-down approach and I'm taking the class-based approach. So this is something that obviously there was all the import statements and then all the frames that we wanted to use. This is the kind of an init for the class path tracker. And so in my init, I am actually specifying ROS node, which could be like what I'm calling, it could be into the name equals main function, but then I'm just defining it over here for now. I can change it later on. The parameters I'm defining at this point, which would be my lookup distances, the limiter, the time data, if I need that, wheelbase multiplier, if I have to adjust sometimes the velocity, limiters, the gains, and sort of input file. So the idea right now is that you would take the input file, and then that's just sort of CSV file, which basically gives you the X, Y, and your kind of your angle, and you got those points. And right now I'm reading the file. Going forward, we would also have the path planning node, which would actually you can call the path, ready-made path via services, and then you can get the the path file, by calling the services kind of a deal. But that's actually something in the future. But we just wanted to have both. And then I'm writing some subscribers and the publishers over here. So obviously my inputs are the odometry data. That's what I need. That's the first one. Let's see, I have this publisher. Sorry, the subscriber. Let me see over here. So the odom thing, that's what I talk about it. And then the publisher would be my twist and the sort of Acumen messages. So I'm trying to use the standard messages. So nothing's at this point. I haven't made any composite messages, but if I need that, then I'll be used all these standard messages and build one composite message, so that everyone can use that. Then I got the publisher for the goal point, which basically if anyone wants to visualize that, they can do that. And also I am creating 2 frames. The one's the Acumen. Now I am thinking that Acumen frames is mostly static because we know the wheelbase and we know where the Acumen frames is going to be. So I don't need that over here. It will be a static transform in most cases. There will be nothing like special about that, but I'll just think about that. But I just put it over here at this point. And the second frame is the cat frame, which is basically the look ahead frame. And I am also going to actually publish that, the frame. Now, these 2 right now, I'll come to this point later on because I have a question, about those 2 things, which is things are not clear to me at this point, but let's just move forward.
Hey, Sam, I have a question on publishing the caret frame. Is that to broadcast the distance between your vehicle, your base link, and your desired goal?
Yes.
Okay.
So that's the caret frame. That's a constant moving frame, actually. So as soon as I have my look ahead, and I'm actually projecting that, let's say, for example, on a path, right, which has to be on the path. So and that's my a kind of a chasing frame, right? So that the caret frame I wanted to actually build, and the broadcast as a frame, obviously, and to the TF. So that we can visualize that through RVs, and that's one of the goals, so that we can also track that if we wanted to run that into the simulation. So that's the whole purpose over here. But I have a couple of points and the confusions over here, which I will just probably come later on, and then look for some ideas over there. So with that, I'm taking the top-down approach. So all the functions the instant methods over here, they're first of all, I'm receiving the path file. So basically I'm reading the CSV file, and then I'm also receiving the the odometry. So I'm actually converting the messages into my position and the orientation values over here. And then also I'm converting that into the just using the inbuilt TF function where I get the Euler from the quaternion. And then I'm actually finding out my vehicle year, because that would I can derive from my odometry data, right? And then my current state of the vehicle, which needs a little bit more thinking, so I'm not touching at this point. The Euclidean distance is basically the straight Pythagorean, so I wanted to know that if I'm let's say at the very beginning, and then this is the kind of a helper function actually. So at the very beginning, I wanted to actually figure out my closest path. So where I am, which is my, the vehicle localization data versus where the path, is, and then I compute those distances. It will help me figure out that what's the closest point, which I can actually move to for the very first time before I start, actually moving and following the path. The compute the angle between the vectors is pure math. This helps us actually measure the vehicle forward vector versus our look ahead distance vector. So this is like a simple, the calculation where we would get like, and we were using the arctangent too, which is basically gives you the minus pi to pi, the actual signed angles, which is very important for us because we wanted to know that in which quadrant you are, basically. And then we wanted to only entertain probably first two quadrants, right? And quadrants like being going anti-clockwise, so your first, second, third, and fourth. And then you're coming to compute the goal point now that you're at a point where you can compute your goal point. So your goal point would be computed and basically a little bit more math over here. And the reason, whole reason behind this computing the goal point is you just wanted to get the index of that goal point. So my next function is the method is it's the goal point index. Once you figure out the goal point index, now you know that what's your goal point is. And then actually at that point we wanted to put the first, the lookup frame, which is the caret frame. At this point, and so this is kind of an, the progress that I made at this point. The couple of things for now, and then I'm just going to compute the Ackermann frame, obviously the caret frame, and then we need to transform, and then transform back to the base link frame, so that once I get into the base link and I get the transform, and I know that from the base link perspective, what this, the Ackermann frame sinks, and then what the caret frame looks like. All the other transforms, I can get it by querying the TF, because basically my base link's already defined. And then at that point, for both the frames, I wanted to make my base link as a parent frame, but I have to look about like the lookahead frame where it should get attached to. So that's one of the kind of thinking process at this point, that just wanted to make sure that where I wanted to have that lookahead frame attached to, and it's just mostly it's just going to be probably directly in the map frame, just because so that we can visualize that, because everything's oriented based on the map, and then we wanted to know with regards to the map where the constant moving frame is. So I'm thinking that the parent frame could be the map frame at this point, but that's all like WIP kind of sort of things. Then I'm just going to go to the compute velocity and computing the zero angle. So this is like completely top-down approach at this point. What I'm looking into, the couple of things where I'm getting a little bit stuck is broadcasting frames, because the TF2 underscore ROS, it's just basically the whole TF2 that I wanted to broadcast it to. I understood one part, and just going through some of the documentations, and I understood one part that you basically can add a frame, obviously, on the go, which is like dynamic frame adding. This is not a problem. The only thing that I'm confused that when you broadcast that using the TF2, do you have to publish that like using a topic, or this is automatically published to the TF2? So that's a sort of a confusion at that point. I'm not sure. Any help on that is basically welcome at this point. I would have to figure that out. How would I basically broadcast, the frame, and then so that if someone has if some other node has to query it, also they could query it to the TF2. And then they should be able to get the transform from any frame to any frame, sort of a deal. So I am like right now you have seen that to basically the publishers that I put it for the Ackermann and the caret frame, which I think is not right. I just put it as a placeholder at this point, and I think that you should be able to directly use the broadcast, the function from which is provided by the TF2, and then it should actually directly, the broadcast it to the TF2. In which case, we don't have to worry about anything. We don't have to use the topic to manually, publish the frame. Basically, that's what I'm thinking right now. But I'm not clear on the concept at this point. I will be. So that's where I'm at, basically. But if we get to, I get to the point where, you know, we have these transforms already working, and I get to the point where we have the velocity, like in forward x, linear x, and the Ackermann angle. If we can, I can actually compute that based on this info, and then if it just behaves well into the simulation, then actually we can take it forward. That's all I have today.
Well, Sam, that's great.
Questions?
It's so on that TF broadcaster, you're right. It does you send the transform. That's a function, and when you create. I'm not a programmer, so I'm not using the right terms. But when you create that broadcaster instance, then you just publish. So you publish the data, you publish the timestamp, and then parent frame and child frame. But you don't have to tell it like what topic or anything like that, because it knows.
That's what I think. That's how it should work, because internally it would publish it directly to the TF2. Oh, sorry, the TF topic. Even though if I'm using TF2, as long as I have all the, you know, the broadcaster defined in a way that it should be defined, I think I should be good to go. And then any other node can listen to it via listener object, probably, that you have to instantiate that object so that you could also can listen to it. And then if you need any transform, you can also use the lookup transform in order to get the you know, the reference frame and the parent frame, you know, the any lookup between those transform where you got the target frame, the reference frame, or whatever it is.
Okay. It's awesome.
So
yeah, on that on the AutoWare, I was looking at, they pull in a file, a text file, a CSV file, and then they have speed. So I thought that was interesting that they have X, Y, yaw, and velocity in their file, and they consume that. So you can, at each point, I guess, you can tell it what speed you want it to travel. You're on mute.
Sorry. Yeah. So my thinking is, I wanted to get like the minimum input, and if I wanted to build, you know, that file, I'll just process those, you know, the points. And if I wanted to, let's say, if you were going to go with the constant velocity, in that case, I'm no problem. We can insert, you know, the velocity also as the, you know, the parameter, and then actually build, you know, the list of the velocity for those points. And I think that would work just fine. But okay. I'm keeping the option open just in case, if you wanted to use the kind of a the variable, you know, the velocity, mm-hmm. so that you have the limiter, you know, you want it to go like, say, max 10, minimum 5 right now. So I've designed like this right now. So max 10, mean 5, and your constant 5. So you can switch in between, you know, if you wanted to have the variation in your velocity based on your curvature, you can also do that. But if you wanted to use the constant velocity, we can also build the metrics and actually insert that at that point, and you go from there too. I mean, both methods should work.
Okay. Oh, that's awesome. It's fun. It's a lot there.
Yep.
Do you need any help or any like paired programming time or review?
The next part is, like I said, you know, the transform. That's I wanted to work on, and once that's done, I wanted to actually figure out that how I can utilize the simulation so that I can switch. You know, like I need the stage running because I need the odometry data. I need the map frame because that's where, you know, which is going to be localized, you know, with the odometry. But then also we're going to need the path inputs, which is like a few points at this point. Just wanted to make sure that it just runs fine. So those are the next steps.
Okay.
I think it's coming along, but obviously you will have some, the hurdles, some block points where probably I will need some help or inputs at least.
Okay. I made a TF broadcaster for the wheel odometry on the lawn tractor, so that sets up the transform and then calculates the odometry message and then or the distance and orientation and then broadcast the transform. But I can send you that file if you want to look at that, some example file.
That would help, just because I wanted to I wanted to add the frame on the fly.
Okay.
And broadcast that, so that when your program is running, you have that, the CAD frame available for you, and all the other transforms, whatever you think of, like from that frame to map to odom, to base link, and everything. So yeah, that would help. Please.
Perfect. Any other questions on that? Looks like Sohin, you posted that area coverage planner you found.
Yes. It's particularly this person, Howie Choset from CMU. He's done a lot of work, and I was curious how related that was to what Bill was discussing earlier. If you can comment on that, Bill, that would be fantastic.
Did you mean Bill, Sohin, or Sam?
Bill, you were talking about the underground robot and how you had the algorithm, that the search algorithm that would try and minimize the path. I was curious if you had the map at that time or you didn't have the map. And then the other thing is if how you were traversing the area.
Okay. So what I did was pre-calculated waypoints that traveled horizontally from one side of the search area to another. And then at each waypoint that was at a side, I descended. This was searching underwater. So I started from the surface and then went down toward the bottom. And I just calculated the sequence of waypoints, assembled them into an ordered list, and traveled back and forth between the waypoints. It was purely a rather brute force algorithm.
Okay. So you didn't have a map at first, or you had the map and you converted the map into waypoints, basically. So
well, I think for what you're thinking of, the only map that I had was the vertices that described the limit of the search area.
Right.
It was a rectangular-ish area. So I started with those vertices that defined that, and then I calculated basically, if you can see my hand, so the surface area was the horizontal plane. Yeah. I then did a vertical plane at the area that I wanted to search across, and then just calculated the waypoints that were at each edge of that vertical plane. And when I reached an edge, I descended a certain number of meters and then went to the waypoint, which was on the opposite side, and descended. So if you think of it as the way that you typically would mow lawn, it's the lawnmower pattern rotated 90 degrees. And that's all it was. So the only map that I had prior to that was, I know the horizontal search area is bounded by these four vertices.
Okay, yeah, that makes sense. Also, was your robot equipped, or was the algorithm equipped with obstacle avoidance by any chance?
No, again, in the theme and the style of pure brute force, we had no forward collision detection.
Okay,
We assumed that the ocean is a big place and there won't be much stuff in the water.
okay,
And we
uh,
got lucky because, to the best of our knowledge, we never collided with anything.
okay. That helps. Yeah, I've been trying to solve that problem myself. Uh, it's yeah, it gets tougher when irregular geometries get involved, and then
Yes.
obstacles get involved. But yeah, uh, well, feel free to go through these papers I've sent. They 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 try to solve a really interesting problem.
Uh-huh. Yeah. I have implemented other things where, not underwater, but in other ones that are operating on the surface indoors. And that one, you detect an object forward. I mean, the simplest brute force way to do that is calculate an intermediate waypoint that's off to one side or the other, and then move to that waypoint, and then look from where you're at towards your original waypoint.
We've been trying to find different planners on that. Someone's been looking into that. It's an interesting problem.
Mm-hmm.
Sam, I was just thinking about this tutorial that I went through when I was learning about TF, and they have this turtle following TF tutorial where you basically have one frame for one turtle, and it just shows up on a graphics thing, a graphical screen, a 2D space, and there's one turtle, and then you move around that turtle, and the other one would just try to follow it. And it seems like that's our solution. I mean, that's the solution what we're looking at.
That is so true.
It's just funny.
So, and then that tutorial is really nice. It's got, and then I've been looking into it. Also, it's got the add frame tutorial for TF2, which probably, if you're looking at it, you should be looking at TF2, basically. The first one that is just a turtle following turtle is basically you got the reference frame, and then you have other frame like actually the very static distance apart, and then that's how just one move, the other move, because they're like kind of following it. But yeah, the concept is similar for the look ahead frame, just because that would be like a sort of a chaser frame, which is the frame.
Yeah, so the original turtle would be the carrot probably, and then our follower would be the robot. Possibly.
The problem is where you would place the turtle.
Yeah, it usually just spawns randomly.
So and that's probably the important step, and that's where you need to figure out your look ahead where you wanted to put that point on, and it has to be on the path. So it's constrained basically, but once you figure that out, following it should be a little more easier, and then that would make it up for the pure pursuit.
Yeah. I was just it was a funny thing that came to my mind. It definitely, I wasn't serious about it, but it seems like it's the solution to all of our problems. Like a turtle is going, and then the other one's following, and just simulate the first turtle, and you have your solution.
No, I agree.
when you see it, it's supposed to follow right at the same moment. But there's a lag. So when you try to do it on tutorial, it would seem like it's following, but it's supposed to be copying the TF. So
Yeah, I wish that'll be that easy.
yeah, I think you're doing great work. Thanks for sharing.
Thanks, Sohin. Yeah, the sample example is also for the people who's trying to learn RS, how I'm learning, and that would, once we have this code out, basically we'll just, I'm leveraging all the standard practices. I'm trying to wherever I can, but I would actually also help someone write the clean code probably. And someone would review my code too, So just wanted to make sure that everything's at least looking fine.
Looks nice. I like your comments and the way you describe each of your functions. Very clean.
Yes, that's the one thing I'm learning, and that's where actually the whole flow top down would make sense. So that if I have to refactor it anytime, or if I have to actually put it into some other code, and I need more nodes, basically limiting to like a one abstract per function kind of a deal, so that it's clean. I have to take it out from somewhere. I have to call that function directly. From somewhere, I should be able to use that too, because all it just does is based on the input, it just computes. So that's what I'm trying to do. Just a little more cleaner sort of things, which is easy to maintain, maybe.
You bet. Kalyan, do you have your mic hooked up today?
Oh, Mike? What was that?
Yeah, I was just wondering if how your project's going and
So I'm working, yeah, I don't have much to share, but I'm working on some object detection project. Maybe in a couple of weeks, I might have something to share.
Sorry. So I thought, Kalyan, that I actually sent a message to Kalyan, and I thought that that's probably you are. Is that on the Slack? What's or maybe, yeah, just on the Slack. Actually, I sent you a message, but I'm thinking that that's probably a different person that I sent a message to, I guess. Did you?
I did not get any message, so.
I see. And what's your username? It's KVEMISHE at the Slack too?
Yeah, but I think my name shows up as Kalyan, at least when I open up the Slack.
So, sorry, but it's KALYAN, right?
Yes, yes.
I did send you the message, I was like, actually, that was the follow-up from the kind of a short tutorial that you had for us last time, and I said we should actually create a new channel.
Okay.
Yeah, absolutely, and then actually get whoever's interested, into the project that you have started, and if you're willing to share, then that'd be a cool thing. We got the GitHub. You can also post the repo there, and then can invite anyone who wants to actually work on it or collaborate. That may be a good idea. And also, if you like new channel, then I think we can have a new channel too, right, Matt?
Yeah, what do you want to call it?
Oh, I haven't thought about that part.
Stumped you.
You did. I was thinking that, yeah, this should be a new channel. It's so interesting, and then what you taught us last time, with all these insights, Kalyan, was just great. All right, all yours now.
No, that's a good point. Maybe we could have a separate channel for perception on its own, and whatever we like. I would be happy to share my work on that channel.
Perception it is.
There you go. You got it.
Yeah, and I'm sorry. For some reason the message didn't come through, so I apologize, Sam, if I didn't respond.
Did you get the message though? Because I may have sent it to the another wrong person maybe.
I didn't get the message. Can you
Oh,
try
you did.
sending another message while we are on the Zoom? That I can make sure that I'm getting messages too. I'm not losing it.
Okay, cool. All right. So I just want to make sure that I sent all right person the message. Cool. Matt, on the side note, I'm also actually working with one of the person who's sort of interested in indoor farming, and pretty much if that person's if it's interested and joins the our group, the person basically also can lead the efforts in terms of the indoor farming, and whoever's interested in it, we can have sort of separate channel for that, so that simultaneously, also that, the side of the things also in traction maybe. So we'll see. Fingers crossed. I have like at least 2 or 3 persons that might be joining our group, and they're all good. Probably would be a good contributors.
Great. There's some interest. I got contacted about using ROS2 in the greenhouse and trying to switch over a system. And there are also some food computer guys out of Korea. So small greenhouse, but still, I mean, maybe there could be some crossover work there.
Absolutely. I strongly believe that we should have a channel, and the efforts also going into that direction too.
Yep. Excellent. It'll be fun getting, the ground robots talking to the greenhouse, talking to the drones. So if everybody's using ROS, we got the same backbone, we can share information and easily connect up.
I can start dream about it.
Having that standard messages and the communication backbone, I think, would make it very helpful. I don't know a lot about that IoT, but there's some ROS bridge into that MQTT framework also. So.
Oh yes, yeah, that'd be wonderful. Also the drones, they got the Mavros, basically just for the communications, so that makes things easier too. I mean, I've used it just only once, but nothing in detail. It's just basically passing, the one of the tutorial where you just pass the Mavros in order to lift, drone up to a certain height, lighter there, and then just get it down to the ground again, and that was it.
Still. You did that simulation inside a gazebo?
Yeah. And it was the early guys when they first came out with that a few years back. The robotics, now it's the Accutronics.
Yep.
This MARA guys.
Mm-hmm.
That's the one. Yes.
Yep.
Yep.
It's a pretty nice shield that runs on the Raspberry Pi. I did upgrade this to a Raspberry Pi 3. But if you take this case off, on that shield, there's also a CAN on their bus. But
yes.
They have nice I/O, and then you have your PWMs to control your servos.
Yep.
And then it's just a regular Raspberry Pi. So you have USB and then camera. This comes out of Spain.
Yep.
Earl Brain.
The Earl Brain. Yep. There was one that put it onto the like Raspberry Pi Zero, the small version of it. But they also actually put the whole thing, the flight controller, onto that Zero. You know, the Pi Zero.
The small one. I
Yeah.
haven't put ROS on the Pi Zero yet, but I've been tempted a few times, but I get scared.
I, I, I didn't even try. Because at least I'm not sure about the ROS 2, you know, what's the footage of it, but I mean, with the ROS 1, I wouldn't try.
There's like the shell script to put on Kinetic on the Pi. I mean, people are doing it. I haven't tested the shell script, but I thought, I mean, it's only like 4 or 5 lines, and I don't know, it'd be amazing if it worked. I mean, greenhouse automation with Pi Zero at $10. Well, you have Wi-Fi, all the GPIO.
Yeah, in that case, it's a dream come true.
I don't know. Might have some uses there.
That's true. Kalyan, we're waiting on you. When are you ready? Please start. You know.
I'm sorry, Miss, what was that?
Are you going to share something?
Oh,
Or...
no, I don't have much to share this week.
Okay.
I'll probably share something in next 1 or 2 weeks.
Oh, cool. Okay.
So I just created the perception channel. You can jump in there, and maybe we could start consolidating some of the papers that we have into that channel, so it'd be a good reference area for the machine learning and vision info.
Yep, that'd be cool.
Kalyan can be the moderator.
Yep, you're leading us the way into this AI and the machine learning, you know, the whole new world, Kalyan.
I was looking at some processors to do that work. I don't know, there was that paper that we posted up there about the TX2 versus using the NVIDIA graphics card. And the TX2 was like even a little slow to do some of the processing for the autonomous spraying. So they would identify the weed and then turn on the sprayer. So I was surprised that the TX2 had a pretty large failure rate compared to the graphics card that they were using. So still computationally expensive.
What's the alternative, like on the cheaper side, that can be deployed kind of reliably?
I don't know. I'm not in that space.
I'm curious. Was it being used? Was the TX2 being used for training purposes or for just implementation?
For implementation, for trying.
Because there's these small sticks, the Mobius stick or something by Intel. So if you have if you have a pre-trained network, those chips are pretty cheaper, you know, as compared to a graphics processing unit, even the TX2. So I was thinking perhaps a good way or a way to deploy these pre-trained models is to just have that model like pre-trained and then at some other computationally powerful machine, and then just use smaller machines to use that training data to come to conclusions, like, or to detect stuff. Because I know these cell phone manufacturers like Google, they're doing something similar, where they have a dedicated AI chip, which is pretty cheap, uh, than a graphics card like an NVIDIA graphics card, a full-size graphics card, or even the TX2. And what they're doing is they have these pre-trained models online, and they just send over-the-air updates, and the camera system becomes smarter just by use of that small chip. So that might be a way to address the expensive computation.
Yeah, I was really surprised that you can take a look at this paper. It's basically development of low-cost setup for spraying. I'll post it here.
And also, I think, Matt, did you find a tutorial on Udemy which showed how to transfer the models to Movidia Stick? I think the Movidia Stick is $75, but it's pretty cheap for some of these computations.
Yeah, that class looked pretty good. It talked about, I can post a link to that, where they go over how to set that up.
Uh, since we are on the topic, can I share something?
Yes.
I wasn't initially thinking, but the spirited conversation here made me share something.
You cut out there.
Can you guys hear me?
Yep.
Share something. Okay, so one of the projects which I drafted a couple of days ago was want to create a web page where people can upload the image, and the software will detect the objects in the image. So the idea would be, once it detects the object, we can use it for collision avoidance or speed separation and all those things. So one of the goals is use object detection using CNN. So the idea here is to create a web page. Initially, anybody could come in and upload their images and see if the objects are being recognized properly. Once it is done, you could download the model from there, and you can run that onto any hardware like Movidius. And people will also have the ability to upload their own data set to that web page. And then it will start training on that data set also. And then once you click download on the page, it will give you a model that you can run on Movidius. So this is a side project I have started to work on. So hopefully, maybe in a month or so, we can have a website where everybody could bring their own data set, load it, and then download the model. And then I'll probably post some links on how to transfer that model to Movidia Stick and run that. So it's pretty early in my mind, but I'd be happy to share this. And if anybody else is interested in working with me, I would gladly take their help.
Excellent idea. So that like trains the data. You upload your data set, it trains it for it, and then you can download the model.
Mm-hmm. Exactly.
Yeah.
You don't have to worry about all the programming aspect.
I like it.
Yeah, that's a very good idea.
Cool.
That's a lot. We're made it to 9 o'clock here. Is there any other comments or things for this meeting?
I don't know if you have had a chance to take a look at Lobe, but it's a pretty amazing project, something on the lines of what you were mentioning, Kalyan. These guys were just, Microsoft just bought them out. Pretty fantastic stuff. I asked to get a beta access, but I still haven't heard from them. So,
What's the name of the company?
Lobe, I just shared the link here.
Oh, yep.
That looks pretty interesting.
Yeah, it's fantastic. But yeah, it would be cool if you could do that again, and you get bought out by someone else.
We have our own stuff for agriculture.
Yeah, but it's pretty cool. Yeah, they spent a lot of time working on it. So
Very nice.
yeah, that's what I have.
Awesome. Well, great seeing everyone. Thanks for all the work. It's pretty fun. Making a little bit of progress.
Inch by inch.
So Walter would say we're moving like a herd of turtles. Just good for Ross, right?
Is that a rock joke?
It should be a Ross joke. Yeah.
Yep.
All right. You guys have a great week. I'll talk to you later.
Well,
You guys.
Goodbye.
Good night.